Good day and welcome to my YouTube channel. In this tutorial video, we're going to be looking at panel data estimation using panel correlated standard error. Most panel data estimation techniques requires the absence of cross-sectional dependence in the model. They require the absence of autocorrelation and the absence of heteroscedasticity. But this method of panel estimation, panel correlated standard error, is so sophisticated that it controls for cross-sectional dependence, it controls for heteroscedasticity, it controls for autocorrelation. What I'm trying to say is that there could be presence of cross-sectional dependence, there could be presence of autocorrelation, there could be presence of heteroscedasticity, and yet these estimation techniques will give you a reliable estimation. In fact, one of the important requirements for using this method is that your model must fail the cross-sectional dependence test. Okay, now before we jump into this model proper, I'd like to list for you the condition that must be met before you employ this method. The first condition is that the time frame, okay, the scope of your study must be large. The time frame must be large. Okay, by largeness, I mean it depends on how you define your largeness. Some would say 25 years and above. Okay, some would say 30 years and above. So it depends on what you call long time period. And in addition to that, your cross section must be less than your time period. By your cross section, I mean the country or company or the items you are investigating, the unit. Okay, you are investigating. All right. So that is one condition that must be met. The second condition is that it must fail the cross-sectional dependence test. All right. It means there must be presence of cross-sectional dependence in your model. If you do not know how to conduct a cross-sectional dependence test, or you don't know how to interpret it, please check out this video. Okay. It is you have a perfect explanation for cross-sectional dependence test and how to interpret your model. Okay. The next test you need to conduct is the panel unitary test. You need to conduct unitary test. One of the requirements is that at least some of the variable must be non-stationary. By non-stationary, I mean they are not stationary at level. Okay, and most importantly, the dependent variable. Okay, it must be non-stationary, and because this model is a static model and long-run model, once your series are not all stationary, we require you conduct a co-integration test. Okay, co-integration test will tell you whether or not there's a long-run relationship in the model. Okay, if you do not know how to conduct this if you do not know how to conduct co-integration test, please you can check out this video on my channel. Okay, so that is very, very important. Okay, remember conditions for using this panel data estimation techniques. Number one, you must have a long time period, and in addition to that, your cross section, your n, must be less than your time period. Okay, that is very important. Number two is that the model must fail cross-sectional dependence test. I mean, there must be presence of cross-sectional dependence in the model. Okay, you can find what cross-sectional dependence means on the interpretation of the model in this video. Another thing is that you need to conduct unitary test. How to conduct unitary test and how to interpret it, you find it in this video. Very detailed explanation given. Okay, we expect that at least some of this variable are non-stationary. All right, especially the dependent variable. And then we expect that you conduct co-integration test to establish long-run relationship in the model. All right, without wasting much of your time, let's jump into this estimation. Before you do panel data and Stata, you need to declare your variable as a panel data. Okay, so to declare a variable as a panel data, you type stset, then cross ID. It depends on what you use to proxy yours, and then you type here. Once you do that, you see panel variable strongly balanced data. Okay, the time frame is between 1980 and 2001, and then there's a year increase. Okay, so now for the sake of this tutorial, I selected 5 African countries. Okay, with a time frame between 1918 to 2001. All right. So look at the data. I think I have Nigeria here. I have Ghana. I have Togo. I have Gabon, and then I have Niger. Yeah, those are the five countries. And the variables of interest there, the external debt, FDI, and real GDP. Okay. The variables they are transformed. I mean, they've been locked transformed. Okay. The real GDP will be the dependent variable, while FDI and external debt will be the independent variable. Yeah, this is solely for the sake of this tutorial. Yeah, because we're going to be trying different simulations, I would like that we go through the menu driven approach. Okay, so to do this panel data analysis with panel correlated standard error, you come to statistics and then you come to longitudinal panel data, and then you come to contemporaneous equation, and then you find what you're looking for: regression with panel correlated standard error, PCSE. All right, when you click on it, you will see these boxes. This is dependent variable. Here I'm going to be taking the transformed GDP, real GDP, and the dependent variable here will be the transformed FDI and the transformed external debt. All right. There are lots of options you can try out there. We have you want to say that there is no autocorrelation in the model. You try out when there is no autocorrelation, or you want to say, okay, there is low level autocorrelation, or you want to try that there is panel specific autocorrelation. Do not forget that at the beginning of this video, I had explained that this estimation technique is so sophisticated that it controls for cross-sectional dependence, it controls for autocorrelation, it controls for heteroscedasticity. Now, this tells you how the autocorrelation is to be conducted. All right, this tells you the heteroscedasticity approach to the heteroscedasticity that should be factored in. Okay, heteroscedasticity level that should be factored in the estimation of the model. So now we are going to start. Let us start with no autocorrelation. Okay, we are going to explore all these options and see what happens to our result. So we are going to start with no autocorrelation, and let's say we consider singular OLS residual. Okay, and for heteroscedasticity, we look at panel level heteroscedasticity and correlation across panel. This is usually the default mode. Okay, if we click on this, let's see what we have. All right, voila, see our result here. So this is real GDP. This is our FDI. You say that FDI is negatively affect real GDP. Okay, external debt here positively influence real GDP. Of course, they are statistically significant, but do not forget that these data were generated for the sake of this video. All right, so that is that. All right, let's look at the let's consider a situation of low level autocorrelation. Remember, you go to longitudinal data, you come to contemporaneous correlation and regression with panel standard error, panel correlated standard error. So right now, let's look at AR1. Let's still maintain this, okay? And then let's see what happened. Or let's look at panel level heteroscedasticity and correlated across panel default. Okay, let's see what happened. It looks like here the signs change. The significance FDI is no longer significant. Okay, this is still positively this still positively affects real GDP and statistically significant. So we see this. This is not as robust as the first estimation, okay? But then this is just to take you through other phases we have in the estimation techniques. All right, let's consider the third option. Let's look at panel specific AR1, and let's still maintain this level. What do we have here? Okay, similar to what we had in the last equation, the last regression. I mean, the FDI is still not significant. All right, and then the sign changed. Okay, we have external debt still positive and significant. Okay, let's go and explore. Then let's go and adjust the heteroscedasticity and see what we have. Okay, contemporaneous correlation. You come in, and then let's say we're back to now to correlation, but this time around we are looking at panel level heteroscedasticity. What do we have? Okay, it looks like the first model we estimated. You see, if the eyes negatively affect rigidity, statistically significant, external depth positively affect rigidity, statistically significant. All right, let's go again and see what happened when we change it to AR1. Okay, it looks like it's similar to what we got and our second estimation when we factor in autocorrelation. Okay, see the result here. The FDI is not statistically significant in this case, and that is not positive. Okay, let's see what we have when we try out panel specific AR1. Okay, this is similar to the last simulations we did. All right, let's see the third one. Let's see what we have. Let's say now we want to look at when heteroscedasticity, when there is independence across panel. Let's see when we have independence across panel for the error. Let's say let's start with no autocorrelation. Okay, this is similar to what we had in our first regression. I mean, FDI is negatively affect rigidity and statistically significant. This is positive. Let us see what we have when we consider a case of low level of the correlation, AR1 positive and not statistically significant. I think the issue is with the FDI. Okay, FDI. Okay, let's see what happened when we consider when there's panel specific AR1. Alright, the result is similar to what we had in the last regression. So if there is still positive. Alright, so these are all the options you can explore using the Panel Correlated Standard Error. Okay, it's a very sophisticated techniques that allow you to explore various options, okay, relating that ranges from autocorrelation to heteroscedasticity. All right, before you can use this approach, I want you to know that there are certain conditions that your model must meet. Okay, number one, your model must fail the cross-sectional dependence test. Okay, you have I have a video on cross-sectional dependence for those that do not know how to conduct and interpret it. You can find a robust explanation for it. You need to conduct unit root test, and it is expected that at least some of the variables are non-stationary, especially dependent variable. Okay, and we expect that you conduct co-integration test to establish long-run relationship in the model. Most importantly, we expect that you have a long time frame, and the number of cross sections is expected to be less than the time period. All right, thank you. We've come to the end of this video. You do want to like, subscribe, drop a comment, and share this video with colleagues. If you've not subscribed to this channel, you're missing out. Do want to subscribe and share with friends. Thank you. See you in my next video.